Hello guys, in this video I'm gonna have a full description of algebraic operations in physics but generally in science. In science we are faced with quantities, not numbers. You know that quantities are represented in numbers but they are different because we measure them. Basically, algebraic operations are divided into four different categories: addition, subtraction, multiplication, and division. But you know that addition and subtraction are basically represented with the same rules, and multiplication and division in different group. First, let's concentrate on addition and subtraction. Okay, let's start with a practical case. Suppose that I have a table here. The length of the table has been measured to be 231.7 centimeter. A very small microbe has been attached to the end, and the length of the microbe was measured to be 2 times 10 to negative 6 centimeter, which is very, very precise measurement. Anyway, 2 times 10 to negative 6 is very, very precise compared with the length of the table. What's the answer of L1 plus L2? You may say, okay, I will use a calculator and it's very easy. But please stop using a calculator. These are quantities and they are not that easy to work with. Let's learn the rule. I stack the values as the same similar number places are in the same columns. And then I will start from the leftmost figure. For the first term, the leftmost figure is 2, and here I have nothing. As here, I'm allowed to put a 0. 2 plus 0 will be 2. But why I'm allowed to put a 0 here? Because this 0 is a leading 0 and will not change the total number of significant figures in the second term. So it's okay. For the second value, it's a second figure, 3 is added by 0 again, and I will get 3 again. 1 is added by 0, I will get 1. And if I pass the decimal point, I will get 7, which is added by 0, and the answer is 7 again. What should I do if I go any further? Do I have any 0 here? No. If you add a 0, it's not allowed. Because you know that if you put a trailing 0 here, you will change the total number of significant figures in the first term, and it's not allowed. So please stop doing that, and you have nothing to do. So you should stop here. There is nothing to do and forget about the rest of figures. So the answer will be 231.7 centimeter. What happened to the microbe? Nothing. It disappeared. Nothing. What's the rule? Pay attention. In addition and subtraction, the answer should be as precise as the least precise term. Pay attention. In the first term, L1, the last right significant figure, which is 7, is in the number place of tenths. But the second one, which has just one significant figure, has the number place of 10 to negative 6, which is very, very precise compared with the first one. So I will care about L1, not L2, the less precise term. Here you may make a mistake. You may say that, okay, so if I add the two values, always the answer will be the same as the less precise term. No, it's not the same always, but the same precision. What do I mean? Let's go to the next example. Okay, let's apply the rule for this case. 35.4 is added by 12. Mathematically, the answer is 47.4. But pay attention. For the first term, the last right digit is in the number place of tenths. The last right digit for the second term is in the number place of ones. So I will care about ones because it's bigger, and 12 is my less precise term. So the last right digit in the answer must be in the number place of ones. What should I do with that 4? Anyway, I should apply the rounding rule. 4 is smaller than 5, so I will round it down and the answer is 47. Let's go to the next example. Suppose that I have 35.65 added by 12.1. Mathematically, the answer is 47.75. But pay attention. For the first term, the last right digit is in the number place of hundreds. The second one has the last right digit in the number place of tenths. Which one is greater? Of course, tenths. So the last right digit in the answer must be in the number place of tenths. What should I do here? Again, I will apply the rounding rule. 5 and greater than 5 will be rounded up. So the answer will be 47.8. Okay, let's do this one. 1.48 times 10 to 6 minus 3 times 10 to 5. As you see, they have exponents, and exponents are not the same. The first exponent is 6, the second exponent is 5. They must be similar, so I should make them similar. Arbitrarily, I take the second one and change it. It could be written as 0.3 times 10 to 6, Now, the exponents are the same. Temporarily, you should forget about 10 to 6. Suppose that I have 1.48 minus 0.3. Mathematically, the answer is 1.18. But the first term has the last right digit in the number place of hundreds. The second one has the last right digit in the number place of tenths. The answer must have the last right digit in the number place of tenths. So I should apply the rounding rule. As 8 is greater than 5, it's rounded up. And so the answer is 1.2. Then I should take 10 to 6 back. So the final answer will be 1.2 times 10 to 6. I hope you have got the point how to do subtraction and addition. But the next case will be multiplication and division. The rule we apply for multiplication and division will be completely different. So let's start with example. Okay guys, please carefully pay attention to this case. I have a triangle, and the length of this triangle is 2.5 centimeter and the width has been measured to be 1.33 centimeter. By definition, the area of this triangle will be product of the two values, which is mathematically 3.325 centimeters squared. But we have a special rule for that. In multiplication of quantities and also in division, you must pay attention to the number of significant figures. First term has the total significant figures of 2. The second one has the total significant figures of 3. So the answer must have the least number of significant figures in the term multiplied. So the minimum number of significant figures will be 2. The answer must have just 2 significant figures. What should I do with this 25? It's very easy. You should apply the rounding rule. First, forget about 5 and pay attention to 2. If you concentrate on 2, 2 is smaller than 5, so it's completely ignored. So the answer will be 3.3 centimeters squared. The rule is this. In multiplication and division, the number of significant figures of the answer will be equal to the least number of significant figures among the terms. Let's work on this example. 200 multiplied by 6. Mathematically, the answer is 1200. But pay attention, because of this decimal point, all the trailing zeros are significant here. So the first term will have 3 significant figures. The second one will have just 1 significant figure. So the answer must have the least number of significant figures. So I should keep just the first digit, 1. But what should I do with the second, the third, and the fourth figure? It's very easy. First, you should convert it to scientific notation, and then pay attention to the rounding rules. I should keep just 1. So as the 2 is smaller than 5, it is completely ignored. So the answer after the rounding down will be 1 times 10 to 3. The other example is 126 multiplied by 7. Mathematically, the answer is 882. But the first term has 3 significant figures. The second term will have just 1 significant figure, so the answer must have just 1 significant figure. What should I do with this 8 and this 2? First, I should convert it to scientific notation. 8.82 10 to 2. Then, I should apply the rounding rule. As the 8 is greater than 5, so it is rounded up, and the answer will be 9 times 10 to 2. In this case, I have 5.1 times 10 to 4 multiplied by 0.7 times 10 to 5. First, I should pay attention to the exponents. 10 to 4 and 10 to 5 are multiplied, and then I will get 10 to 9. The coefficients are multiplied by, and I will get 3.57 separately. Forget about 10 to 9. Forget about 10 to 5. Forget about 10 to 4. Just pay attention to the coefficients. The first term has the coefficient of 5.1, which has 2 significant figures. The second one has just 1 significant figure, so the least number of significant figures is 1. The answer must have just 1 significant figure, so I should keep the 3. But as 5 and greater than 5 are rounded up, I will get 4 times 10 to 9. In this example, I have a division. 4.3 times 10 to 7 over 2.5 10 to 2. First, pay attention to the exponents. 10 to 7 over 10 to 2 will be 10 to 5. And if I divide the exponents, I will get 1.72. Okay, in the numerator I have 4.3 and the denominator I have 2.5. Denominator has 2 significant figures in the exponent. Numerator has just 2 significant figures again. And so the answer must have 2 significant figures equal to one of them. So I should pay attention that 1.7 is my goal, and I will get rid of 2. 2 is smaller than 5, so it's easily ignored and rounded down. So the answer will be 1.7 10 to 5. Carefully pay attention to this case. 2.34 times 10 to 3 is raised to the power of 2. I can write it like this. The exponent to the power of 2 and the coefficient to the power of 2 separately. 10 to 3 to the power of 2 will be 10 to 6. And 2.34 could be easily separated like this. 2.34 multiplied by 2.34. Okay? They are the same similar terms. Mathematically, if you multiply them, you will get 5.4756 times 10 to 6. But pay attention, here I have just 3 significant figures, the second term likewise, so the answer must have just 3 significant figures. I will keep 5, 4, and 7, and I should work on this 5. 5 and greater than 5 are rounded up, so after rounding up, I will get 5.48 times 10 to 6. This is the answer. And the last example. Find the area of a circle with radius of 4.589 centimeter. Pi is given to be 3.14. As we know, the area of a circle is obtained by pi r squared. I substitute the values. Mathematically, the answer will be 14.40946 centimeters squared. Okay, let's count the significant figures. The first term is pi. Pi is not a quantity. Pi is not measured, so it doesn't have any significant figures. Pay attention. This is a very important note. So just I will concentrate on the second term. which is 4.589 multiplied by 4.589. It has 4 significant figures, so the answer must have just 4 significant figures. As 9 is greater than 5, it's rounded up, so the answer will be 14.41 centimeters squared. I hope you enjoyed this video. If you enjoyed it, please do not forget to push the like button. See you in the next videos.